So today we're going to talk about the remainder theorem and what that does, and then what the remainder theorem does. The first thing we got to do is to synthetically divide. So what we're going to do is write the coefficient of all of the top numerators. So it'd be 1, 3, and -10. Remember, then we take this here and write it as the opposite. So that'd be -5 on the outside. Bring down our 1. We multiply 1 times -5 gives me -5. We always add. So 3 plus -5 is -2. -5 times -2 is +10. And when we add that, we get 0. So here, remember that box is our remainder. We have -2 here. And every time we move to the left, we add an x. So our factor would be x minus 2. It says, based on the work above, what conclusions can you draw about the divisor of the rational expression when the remainder is 0? And what we say is our answer is a factor of the, I'm going to abbreviate, but it's supposed to be polynomial. So I'm going to put polynomial. Okay? So here's another one. And we have x to the third minus 7x minus 6 over x minus 4. So we're going to synthetically divide. So we're going to put our coefficient. So it'll be 1, 0. And the reason we put 0 is we go from x cubed to x squared. So we need a placeholder. Then -7. Then -6. Okay, again, write that out here as the opposite. Bring it down and multiply. So that'd be 4, which add is 4. We got 16. When we add, that's 9. Then we have 36. So when we add that, we get a remainder of 30. So it asks, what is our remainder? So in this case, our remainder, or our r, is equal to 30. So then it tells us find m of 4. And that's just by saying, using the m equation, which is x cubed minus 7x, I think it was minus 6. Put 4 in for x and simplify. So we have 4 cubed minus 7 times 4 minus 6. So that's 64 minus 28 minus 6. And we end up getting the exact same answer of 30. Okay, so it says, based on our work above, what connection do you notice about the m of 4 and the remainder of when we did the division? And we're going to write they are equal. They are equal to each other. So let's do another one. So this time we're going to do x to the 4th minus x to the 3rd minus 3x squared plus 4x minus 1 all over x minus 1. So we're synthetically divide again. So we have 1, 1, -1, -3, 4, and -1. And then we're going to put this 1 here on the outside. Bring it down. 1 times 1 is 1. That gives me 0. 0, 0. That's -3. -3, which is 1. 1, and then a remainder of 0. So that's find the quotient. Okay, so when we simplify this, so we have 1 minus 3x. We don't need an x squared, so then we move on to the next one, which is x cubed. So there is my polynomial with a remainder of 0. So it says find a of 1, so using the a of x equation, which is x to the 4th minus x cubed minus 3x squared plus 4x minus 1. Find a of 1, so it'd be 1 to the 4th minus 1 to the 3rd minus 3 times 1 squared plus 4 times 1 minus 1. So it's 1 minus 1 minus 3 plus 4 minus 1. And what we end up getting is 0. 0. So again, our conclusion is they are equal. They are equal. So what the remainder theorem basically says is if we divide and we get a remainder of 0, then that divisor, that bottom, that denominator, is a factor of the original polynomial. So it says, how can the remainder theorem help us find solutions to a polynomial? We can set them equal to 0. Okay, when we do that, then we can solve. Okay, so it says let's practice here. And it says, is x minus 4 a factor of that polynomial? So how we do that is we synthetically divide. So we do 2, -3, -18, and -8. We put 4 on the outside. And what we're looking for, do we get a remainder of 0? So that'd be 5, 20, 2, 8, 0. Yes, we do. So x minus 4 is a factor because our remainder is 0. That's according to the remainder theorem. So it says if x minus 4 is a factor, write the polynomial we get in factored form. Okay, so fact x minus 4 times the rest of this polynomial here. So we go 2 plus 5x plus 2x squared. Okay, and then it says if it's possible to keep factoring, factor it some more. So what I'm going to do is I'm going to take this 2x squared, and I'm going to do the x method. Remember, it's a times c. That gives me 4, 5 in the denominator. So we have 4 and 1. So then we have, remember, it's always ax. So 2x over 4 and 2x over 1. So this simplifies to x over 2. So that would be x plus 2 in that one. This one would be 2x plus 1. So our final factored form after we do it all will be x minus 4 times x plus 2 times 2x plus 1. Here we're going to do another one. Determine if the binomial x minus 4 is a factor of the polynomial x cubed plus x squared minus 16x minus 16. If it is, then completely factor the polynomial. So again, we have to use synthetic division. So we have 1, 1, -16, -16. Again, we're going to put 4 on the outside. Bring down our 1. 1 times 4 is 4. That gives me 5. 20 gives me 4. 4 times 4 is 16. Gives me a remainder of 0. So x minus 4 is a factor. Okay, so x minus 4 is a factor. So now we have the polynomial. So we know it's x minus 4 times the rest of this. So it's 4 on the back end plus add an x every time we move to the left. 5x and x squared. And then we have to see if we can factor that. A times c would give me 4, 5. It'd be 4 and 1. And it'd be 1x and 1x. Neither one of them reduces any further. So it'd be x plus 4 times x plus 1. So our final result would be x minus 4 times x plus 4 times x plus 1. All right, the last one. Which of the following is the dimension of a box with the volume 2x to the fourth plus 4x to the third minus 18x squared minus 4x plus 16? What you would have to do is test each one of these out to see if you get a remainder of 0. I know the answer, so I'm going to go ahead and work it out. Okay, the answer is B. Okay, so we'll use 1. Bring down our 2. 2 times 1 is 2. Add, that gives me 6, which gives me -12, which gives me -12 here, which gives me -16, -16, and you do get a remainder of 0, which is why x minus 1 is a factor.